Hello. Today's topic is outstanding loan balances. Say if you wanted to, well, if you buy a house and you take out loan, and after say several years you have enough money, you wanted to pay off the loan, then you would need to know the balance at that time. Let's draw a timeline to illustrate the whole situation. So time zero, time one, time two. And let's say, assume you pay Q in the end of each time period. And then say this is our time K, and K plus 1, Q, Q, and finally N, and it's the total number of the periods. Excuse me. Normally, in simplified case, we're going to just treat the last payment as Q, but sometimes and there's an error because you don't get integer value. Actually, you don't get integer number of cents. Sometimes you round up. So normally the last payment will be slightly smaller than Q. In some case, we just don't treat them differently, just treat as Q. Sometimes we treat them differently because sometimes we require to have some kind of difference to make it more accurate. Okay? So our task is to figure out the balance at time k. Let's call it OLB, which is outstanding loan balance at k. Normally, it's the end of the case time period, and normally it's after this payment is paid, after this last payment was paid. Okay. There are two ways of getting the formula of this amount, OLBK. One way is called the retrospective method. What it means is that you look back and see, um, say this is our loan, how much loan is accumulated at time K, and also how much you have paid based on K payments with each payment Q. So you're gonna move, you're not move, you just calculate the accumulated value of this loan amount at time K. So that will be L times 1 plus I. Let's assume I is the interest rate for per time period. And you have K here. So that's accumulated value of L at time Q. So L happens at 0, but we're looking for the value at time K. And then subtract what we have paid. We paid K periods of Q dollars per time period. So I have Q times its accumulated value, so it's S. It's the annuity, okay? And I have K here, angle I. So this is the retrospective method. Another method is to look forwards, so it's called the perspective method. What means is that we are looking at, let me use what color? Okay, so we're looking at this balance as the present value of this part of the annuity is kind of left over. Okay, so that equals Q times A sub. How many payments? You have paid K, and there are totally N payments, so N minus K, angle I. So assuming all the payments are leveled, they're all the same. If we wanted to make the difference between, we want it to be more accurate, because sometimes we have a smaller payment for the last payment, R, then it will be Q times A sub N minus K minus 1 angle I. So this is the um, let's say put this n minus 1 here, and you have q here, and then this q say replaced by r. So you have a n minus k minus 1 payments of q each for each payment, and then you need to add the last payment, which is r, is normally sometimes smaller, a little bit smaller than q, times 1 plus I to the negative n minus k. Okay, so that's these are two formulas we use, actually three, but these two are very similar. Depending on whether the question is asking, sometimes we use the simpler version, sometimes we use this more complicated version. All right, let's look at some examples. Example 1, Sasha is obligated to repay a loan made on the first of the month by paying $80 at the end of each of the next 30 months, including this month. The effective monthly rate on the loan is 0.4%. Find Sasha's loan balance immediately after her 12th payment. All right. We can draw a timeline. Probably not that important for this problem, but I think it's a good habit. 0, 1, and then dot, dot, dot. Totally is 30 months. So let's put 30 here. And then we're looking for the balance after 12th payment. Let's put 12 here. Paying 80, 80. And then you have, this is 13, 80 and 80. Okay. The loan amount is not given. All right. We can figure that out. For example, a loan is actually $80 times a sub angle 30 and monthly 0.004. We're treating each month as one time period, and this is the effective rate, effectively monthly rate. So you have 30 and 0.004. But for this problem, it's probably better to use a prospective method because L is not given and the monthly payment is given. So the outstanding loan balance at time 12 would be equal to 80 times 8, present value. You actually have a 20, actually 18 months left, so 18 angle 0.004. That's 80 times 1 minus 1.004 to the negative 18 over 0.004. That number is $1,386.71. You could find L then work with retrospective method, but this method is preferable for this problem. All right. Move on to the next problem. A loan of $20,000 is being repaid by payments of $2,500 at the end of each year, and a final smaller payment 1 year after the last $2,500 payment. The annual effective interest rate on the loan is 8%. Find the outstanding loan balance just after the borrower has made payment totaling $15,000. So $15,000 divided by 2500. That is 6. That's 6 is our K. If we recall the timeline, so that is just K. All right. This is my habit to draw a timeline. 0, 1, 2, and you have 6, 7, and now we have a 18, right? Is that 18? Oh, actually, we don't know that. We don't know how many payments are there total. There are totally. Okay, so we have 2500 for each one, 2500 and 2500. And at n minus 1, we still have a 2500, but the last one we have R is smaller than $2,500. We're looking for the balance here with 6 months, 6 years. For this problem, we do know L, so L is known, which is 20,000. So for this problem, it's better to use retrospective method because one, we don't know N, the second one, we don't know R. Okay, we're able to find all of them, but um, it's just easier to use retrospective method. So the balance equals accumulated value of the loan, 1.08 to the 6, and then minus the payment paid, accumulated value of 6 payments. 2500 times S, it's accumulated 6, and then 0.08. So that is 20,000 times 1.08 to the 6 minus 2,500. 1.08 to the 6 minus 1 over 0.08. Okay, so the first value is 31,737.486. I just keep 3 decimal points. I think that's good enough. The next was 18,339.822. All right. 8226, but I think it's okay either way. All right, and the answer is 1397.66. All right. And if you want, you can find n actually by solving this equation. So the loan. So first of all, you assume you have all the level payments. So you have that times A angle n 0.08. That is 2500 times 1 minus 1.08 to the negative n over 0.08. Okay, and you can solve for n. I think n is about 14. It's 14. And then use 14. You're gonna calculate the present value of the first 13 payments with each payment $2,500. And then you can solve for R. Okay, you can do 20,000 equals 2500 times A sub 13 angle 0.08, and then plus R times 1.08 to negative 14. So you can solve for R. Okay. But for this problem, our main purpose is to find the balance at time 6. So we should be okay with the answer now. All right. Let's look at another example. Okay, it's a little bit complicated problem. So Mr. and Mrs. Harper purchased a house for $256,000. They make a down payment of $40,000 and finance the remainder of the purchase price with a 30-year mortgage at an annual effective rate of 6.5%. The Harpers sell their home at the end of 8 years, just after having made their 96th end of month mortgage payment. The sales price is $282,000, and the Harper's closing costs are 3% of the selling price. And the outstanding loan balance is deducted from the amount the Harpers received and sent to the lender. How large a check do the Harpers receive? Uh, and how much interest did they pay over the 8 years? All right, so let's draw a timeline. I'll put on the top. I think I need some space to work on the numbers. Totally 360 months. Actually, we were given the interest rate, which is annual effective rate, but the payment is a monthly payment. So we needed to let's just change to monthly rate and monthly payment. And 8 years, that's 96. And then it's starting from 97. Okay, that won't be paid. I mean, we're looking for the balance at this time. Okay, so there are a few things we need to calculate first, which is the loan amount first. Loan equals 256,000. That's the price of the house when they purchased it. And the down payment was paid already, so the loan amount is $216,000. So that's the loan amount. Then we need to figure out the interest rate per month, which let's use J. J is 1.065 to the 1 over 12 minus 1. This number is a little bit nasty. 0.005 2617. Let's put it that way. Okay. So we prepare all these. So we need to figure out the monthly payment. Okay, monthly payment. Even though the house was sold at this time, but originally the plan is to pay 360 payments of $Q per payment. Okay, so let's figure out Q. Use this equation. So 216, this is the loan amount, equals Q, which is the payment per month. And I have A sub 360 months with interest rate J monthly rate. The Q times 1 minus 1 plus J to the negative 360 over J. So we can calculate Q to be all right, 216,000 times J. I'm gonna just write J because that number, decimal number, is a bit too long. And then I have 1 minus You could do 1 plus j directly, or you can do the following. 1 plus j to the negative 360 is actually 1.065 to the negative 1 over 12 times 360, which is actually negative 30. So that's just 30 years. Okay, it's 30-year loan. You can do that. That's no problem. So 1 minus 1.065 to the negative 30. So it turns out Q is about 1338.957666 round up. I have 96 cents, 96 cents. Okay, so we have that. Now let's calculate the balance. We need the balance at time at the end of eighth year. We need the balance and subtract that balance from the sale price, and then we also need to subtract closing costs, and then that's the check Harper's would get. So let's find the balance. OLB balance sub 96. And because we have some round up here, the last Q will be a little bit smaller because you round up. That means you pay a little bit more each month. And so probably it's better to use retrospective method to get a relatively more accurate answer. So I use L, which is 216000 times 1 point, let's use 1 plus j. For 1 plus j to the 96, you can use 1 plus I to the 8th. That would be the same thing. Okay, that would be the same. And then you're gonna subtract Q times S sub 96 angle J. Okay. Anyway, you're gonna get $190,800.24. If you use the prospective method, which is Q times A sub, I have a 360 minus 96. That's about that's 264. 264 angle J. So we have 96 payments and we have 264 payments. That number is slightly bigger, so 190,886 cents. Very similar. So if you do both, either way, I think should be fine. But let's just use the relatively slightly better answer. Okay, 24 cents. All right. Now we have the balance. We have the sale price, which is 282,000 minus balance. And then there's a closing costs you need to subtract, which is 3% of the sale price. And we would get 82,739.76 cents. Okay. There's one more question. How much interest did they pay over 8 years? Uh, interest paid. The interest paid, let's put I here, is the total payments, which is Q times 96. That's what Harper's paid in 96 months. And then you're gonna subtract the principal paid. How to get the principal paid? That would be the balance. That's the money Harper's borrowed from the bank, and then the balance at time the end of the eighth year. Sorry, uh, eighth year. Okay, so that's the interest. So this is the difference between the principals and uh, that is the contribution. Well, I mean, this part is the change of the principal. That's not doesn't include interest. Okay, the interest would be the total payments minus principal paid. Okay, and that value is uh, what is that value? So I'm gonna just look at the answer. 啊、$103,000 and $340 and 40 cents. Okay, so I'm gonna just copy it here. It really doesn't matter. All right. That's for this example, and I think that's for today. I'll see you later. Bye bye.